Welcome back. In this video, we are going to solve a problem. We're going to solve a quadratic equation, and we are first going to use the process of completing the square, and then we will use the square root principle. Now, when you move ahead to trig and calculus following this class, this is a strategy, a manipulation strategy that's very important for you to be able to implement. So I like to show it to you, even though in this class you don't specifically have to use this method to solve a quadratic equation. Completing the square is a method that always works every time, and some students prefer it to the quadratic formula. So I'm going to go through the completing the square process. And again, as I said, this is very, very, very important when you move forward in math to be able to use this strategy to rearrange. All right, so what we have here is 3x squared plus 3x plus 4. Now, quickly I would say, well, times 3, that's 12. Are there two factors of 12 that sum to equal our middle term, which is 3? And the answer is no, so we know this isn't factorable. And you might just jump right into using the quadratic formula, which is acceptable, but we want to focus on completing the square. So when we look at completing the square, we do a couple of things. First things first, we always take that constant and we move it to the other side of the equation. So I have 3x squared plus 3x. I'm going to leave a space here, so that'll be equal to negative 4 when I move that 4 over. So I've got this negative 4 on the right side of my equation, and I have this space. And the idea with completing the square is we want to determine a magic number that goes right here so that this is factorable. And I want you to keep in mind that if I'm going to add some number to the left side of the equation, I also will need to add that same number to the right side of the equation, because an equation is balanced like a scale. So if you add 4 to the left, you would need to add 4 to the right, just like with our additive property of equality. All right, so we're going to focus on that magic number. But before we can do that, one thing we want to make sure that we notice or look for is this leading term, is this squared term, does it have a coefficient of positive 1? In this case, the answer is no, so we're going to factor out a GCF. And the GCF on the left side is 3. So I factor out a 3. That leaves me with x squared plus x plus some magic number. And on the right side, I still have my negative 4 plus the same magic number. So finding this magic number is really easy. We have a process for doing it. But before we do that, I want to mention that whatever I add to the left, notice there's a 3 in front, I will be adding 3 of that number. So on the right side of the equation, and if you want to go ahead and write that over there, I'm going to say 3 times whatever that space is, because we don't want to forget that 3. Okay, so now let's talk about determining the number that goes in this space. Well, what we do is we look at b, and we're going to take b, divide it by 2, and then square it. In this case, the coefficient on my linear term, or the b value, is 1. So this is the same as 1 over 2 squared, which is 1/4. So 1/4 is the number that I'm going to add to both the left and the right side of the equation. Now the beauty in this is that now that I've added that 1/4 over here on the left, this is factorable. 1/4 is 1/2 times 1/2. And if you add 1/2 and 1/2, you'll get positive 1. So this is always going to be x plus or minus, depending on the sign, the value before you squared it. So 1/2 squared, right? This is the number before I squared it. So once I factor it, I have x plus 1/2 squared. And on the right side of the equation, I have negative 4 plus 3/4. So negative 4 plus 3/4, that's negative 16/4 plus 3/4. That's negative 13/4 on the right side. Okay. And, again, I just want to emphasize x, this is going to be plus or minus depending on the sign of this squared term. But whatever we had, b over 2. b over 2 goes right here every time. And you can check this by multiplying. You could say x plus 1/2 times x plus 1/2, and it should FOIL to x squared plus x plus 1/4. So we are reverse engineering this number so that we are able to make this very nice format. And now that I have it in my completing the square format, I'm going to continue solving. So I'm going to divide by 3 on both sides of the equation. Dividing by 3, that gives me x plus 1/2 quantity squared equals negative 13, and this fourths divided by thirds is going to be twelfths. At this point, I would use my square root principle to solve. That would be x plus 12 equals plus or minus the square root of negative 13/12. And then I will subtract the 1/2. So I've got x equals negative 1/2 plus or minus the square root of negative 13 over 12. And this is my irrational complex solution. Now, I do need to simplify this negative under the radical, as well as we're not allowed to leave fractions under the radical. I'm going to pause and write that over here to the side for us. And what I end up getting, I do some factoring. So I've got a -1 and a 13 in the numerator, a 4 and a 3 in the denominator. I'll pull the square root of 4 out, 2, -1 out, my I. Now, the square root of a quotient is a quotient of the square roots. So I need to rationalize the denominator. I multiply by 1, forming the 1 by looking at the other denominator. So I use root 3 over root 3. Root 3 times root 13 gives me root 39, and root 3 times root 3 is 3. So I end up with root 39 over 6i. So I have two complex irrational solutions. -1/2 plus or minus root 39 divided by 6 times I. And so this works just like the quadratic formula. Of course, you do not have to use completing the square in this class specifically, but being able to take something and run through these basic rearranging steps to get something that looks like what I'm circling here in the red, this centerpiece, 3 times the quantity x plus 1/2 squared equals negative 13/4. That is going to be important for you to be able to form. So being able to discern b divided by 2 and squaring it to add your magic number to both sides. That's really important moving forward to calculus or trig, which comes before calculus. All right, so I hope that helps you guys understand what's going on here. Please reach out with any questions or concerns because I am here to help. Thanks and have a great day.